Right, okay, this is June 2014, FP1 paper. This is question 2, and it's looking at question 2, part B. Okay, we've already looked at 2, part A. So, again, it's the same function as 2, part A, f of x equals x cubed minus 5 all over 2, x to the power 3 over 2 plus 2x minus 3. And part B is asking us to find the derivative of this thing. Okay, this is pretty bread and butter stuff, you know. I mean, you've probably differentiated so many functions now that it shouldn't be that difficult for you. It should be nice, easy 2 marks to pick up. Actually, this is turning into quite a nice question. Part A wasn't that bad. Part B doesn't look that bad at all. The only thing that's going to cause you a little bit of difficulty is you can't differentiate this function directly at the moment. It's not in a differentiable form. That's quite a mouthful, differentiable form. Yeah, that's right. So, we need to put it in differentiable form. Okay, so the x cubed, we can differentiate that. So we're going to leave that alone. Minus 5, this is what's going to cause us the issue here, because we've got the x on the bottom effectively, okay? It's a fraction, x is on the denominator. So we can keep the 5 over the 2 the same, and then we just multiply it by x to the minus 3 over 2, because remember, laws of indices, at the moment this is effectively 1 over x to the power 3 over 2, you know, and you multiply the two things together and you get this thing, which is how it's written there. It's exactly the same thing. So when you've got 1 over x, that's just the same as x to the power of negative power. Okay. So it's going to become times x to the minus 3 over 2 instead of 1 over x to the power 3 over 2. Okay. 2x, you can differentiate that, that's fine. And the 3, you differentiate that, that's fine. Okay, now it's in a form we can differentiate it in. So f dash x is equal to, remember, whatever you do when you differentiate, use this power, bring it down, and reduce this power by 1. Okay, so it's going to, x cubed is going to go to 3x squared. And then it's going to be minus times negative 3.3 over 2, so that's going to become negative, negative is going to become a plus, it's 3 over 2 times 5 over 2. X to the, well, this thing, we want to reduce it by 1. A little bit of fraction works. That's why it's sort of a little bit more difficult to work with, but you know, you can do it. So you're going to reduce 1 away from this power. Well, remember when we're working with fractions, 1, we want the same thing on the top, same thing on the bottom as the first thing, so it's going to become 2 over 2. 1's going to be just expressed 2 over 2. Okay, and 3, or negative 3, take away 2, is going to become negative 5, and it's going to be all over 2. So it's going to become negative 5 over 2. Okay, just make it really clear. And then the 2x is going to become 2, and the minus 3, remember this is just a constant. It's effectively 3x to the power 0, because x to the power 0 is just going to be equal to 1, so it's 3 times 1, that's fine. Bring this 0 down, the whole thing's going to become to 0, so it's going to effectively take away 0, but we don't really bother writing that. Okay, whenever you see a constant, it's just going to be differentiable to 0. You can also look at it on a graph, it's just going to be a straight line, and differentiate, it's no gradient. Okay, same thing. Now, let's look at this little bit in the middle. It's 3 over 2 times 5 over 2. When you multiply fractions, multiply the tops together, multiply the bottoms together. Okay, so it's going to become 15 over 4. Okay. Now, general rule of thumb, leave it in whatever form you've been given it in. So if you look in the question, there's no negative powers. Okay, the negative powers have been expressed as 1 over x to the power 3 over 2. So always express it in the form you've been given it in. So 3x squared, that's fine, plus 15 over 4 multiplied by 1 over x to the power 5 over 2. Okay, multiply two things together, 15 times 1 is going to be 15, 4 multiplied by this thing is going to become 4, 5 over 2, so 15 over 4x to the 5 over 2, okay, then you're still going to have a plus 2 on the end, and there you are, that is the function differentiated. Okay, where are the marks? 2 marks. Okay, believe it or not, there's 1 mark just for showing the knowledge that if you have x to some power, n, then when you differentiate it, then you just take 1 off the power. You don't even have to say that it becomes n at the front. Okay, as long as you've done it for 1 term, they'll give you a mark for it. So even if you differentiate it wrong, as far as I'm concerned, that's wrong, you know, because there's no n at the front. But even if you differentiate it wrong, as long as you've shown that you know roughly what you do, you'll get a mark for it. Okay, and the answer, of course, is going to give you the extra mark. So there you go.